Hi guys, today we're going to be doing a video of a quick pre-cal review of composition of functions. So you may or may not be totally refreshed on this, but this is just in case you forgot how composition of functions work, especially graphically, because you're going to need to apply this knowledge to limits. So here we go. Okay, so composition of functions, you'll see you've seen two notations for this in the past. One looks like this, f of, and then there'll be a function on the inside. I can get my pen there, f of g of x. So that makes take the g function and put it inside of the f function. You've also seen it written like this with the open circle notation, f of g of x. They both mean the same thing. Today, you'll probably see this notation more than the other one, but it still might pop up, so just be aware. So you'll have problems like this. There's two sections on your Delta Math assignment. The first assignment is just practicing composition of functions. So these are review questions. So you'll have problems like evaluate g of f of 3. So what that means is that I need to first find, sorry, I'm using a new device here, g of, and then f of 3 is going to be on the inside. I need a new color. F of 3. Okay, so what you need to do first is you need to find f of 3. So if you notice, your Delta Math is going to have two graphs. It will have this f graph, and then it will have a g graph. But first, I need to evaluate f of 3. So I'm going to go to my f graph and look at where x is 3. So where the input is 3, the output, which is the y value right there, is negative 2. So f of 3 is equal to negative 2. So then to evaluate the composition g of f of 3, I need to find g of negative 2. So that means I need to go to the g graph, look at where the input is negative 2, and find the output at that point. So the output at that point is 6. So g f of 3 is, I forgot already, 6. And that's the value of the entire composition. So you should at this point be able to go down, type in your answer, 6, and that's correct. So then let's try another one. So this problem has me find g of f of negative 7. So first, before I worry about the g function, I'm going to find f of negative 7. So I go on the graph, on the f graph, and look for where the input is negative 7. I go to the graph to find the output, and it looks like the y value right here is 9. So f of negative 7 is equal to 9. So that means for the composition, I need to find g of 9. So g of 9, I'll go to the g graph, go to where the output is 9, and it's getting hard to see. Maybe I can zoom in a little. Looks like it's right here at negative 5. So I'm going to say that's negative 5. I'm going to go type it in. And that's correct. So you'll have a couple like these, and then come back to the next video to see how your composition knowledge will apply to limits.